So welcome to this presentation. My name is Barbara Gallina, and I'm associate professor at Mälardalen University, working on safety and interplay of safety with other dependability concepts. So the title of my presentation is The New Norm, from solid products to liquid products. What about safety assurance? So as Jan suggested, the intention here is to give a broader introduction. I actually am running two projects, one in cooperation with Bosch and the other one in cooperation with Grundfos. We have Siemens as observer in one project, which is called for the ASafeOps. We are looking into variability management and how to bridge DevOps and assurance. In the other project, the focus is more on traceability, but the challenges are similar in terms of the need of guaranteed quality, assurance, and compliance management. So, outline of the presentation, old style fashion. Context, liquefaction is ongoing. This is a fact. Problem, what about safety? Piece of solution, multi-constant continuous assurance compliant. Preliminary results based on the sprints that I had the opportunity to be involved in. Future work. So, I don't know if you know Zygmunt Bauman. I like this sociologue quite a lot. He died. He introduced the notion of liquid modernity. And here I'm depicting the ice that is melting, okay? And he has started observing that everything was actually liquid in the process of liquefaction. So people were changing a job frequently, and we were in the condition of constant change in all aspects of human life. No? So you change often the job, you change partner, even your identity becomes a project in your life. So we talk about the fluid gender, no? Liquid gender, everything becomes liquid. There is a standard, so if now we move out from the social aspects and we consider also the products that we use, okay, even those products are becoming liquid, okay, fluid. And in the socio-technical context, if we focus on the technical aspect, we see that in 2018, there was a standard on open systems dependability. And this highlights the fact that the border of the system and the composition of the system is becoming open. It doesn't mean that let's say the interfaces are not predefined and will not be rigid anymore. Okay, you can interact with the outside, you can change your internal structure, you can change everything, more or less. And from an industry perspective, still technical, we are moving from Industry 4, where we had these cyber-physical systems, where with cyber-physical system we were considering embedded system a step further interacting with the physical world. We have now cognitive cyber-physical systems. No? We are introducing these artificial intelligence in terms of neural network to make them cognitive, such that they can take decisions. And examples with respect to the companies that I'm working on. So at Grundfos, actually, there is a process of digitalization and there is a process towards openness in pumps. So at Grundfos is leader manufacturer of pumps, and even pumps, they are becoming cognitive, okay? They are including. So we are about thinking digitalization in pumps here, and you can see that there is a lot of connectivity, and there is inclusion of AI looking into deep neural networks. To do what? Imagine that you have your tiny physical pump here, and you want to have sensors or a possibility to monitor the situation in order to understand if maintenance is needed, okay? And you don't want to have a person checking maintenance on a kind of regular basis, okay? But you want to monitor it constantly. So you add a sensor, there is possibility to perform analytics. And if you want to manage water, and water supply is very important, right? It can be a critical infrastructure even. You might want to have billions of connected assets, millions of connected pumps. So we are moving towards open systems. And we are fluidifying this product in the sense that if you start introducing AI and then it becomes an interest, an interest that is, let's say, fed all the time, then you have evolutionary behavior. And the border, again, of your system is not clear since the start. It's not rigid anymore. We move into another context, window lifters. This is the case that we have looked into with Bosch. Even in the case of a window lifter, okay, you want a switch in order to be able to let the window move and close it. But you also want the anti-pinch function, right? Because you don't want to kill people because of suffocation or just pinch the fingers. So even in that context, you see that there is a lot of development. You have the opportunity even to connect remotely and perform press the switch remotely, or including there are prototypes on feasibility study on including AI, neural networks, in order to do predictive maintenance also in that case, because you may have the rubber that is aging, for example. So, and I wish to make an observation that since this is expected to be included into a vehicle, it is of interest to point out that, for example, Audi A6 has 10 elevated to 33 possible configuration. And once, this is just a prediction, just a prediction because they do not exist yet, but when the vehicle will be fully automated, there will be 1 billion lines of code, okay? So a lot of complexity, hard to manage the configurations manually. So, said that, what about safety assurance? So far with respect to traditional methods, this is not so traditional, but it was introduced in the 90s. It's a way of arguing about safety, so drawing. You could even argue in natural language by writing a prose. But the idea is to provide an argumentation where we explain why we believe that a system is acceptably safe. And when we do that, typically we, in a rigid manner, we consider processes, so how we have worked, if we are compliant with the processes that are mandated in the standards, and if the system behavior is acceptably safe, okay? So what does it mean that it is acceptably safe? That I have performed a risk assessment and I have identified how I want to control the risk, and I have shown the traceability that exists between the risk identified and the measure that I have incorporated in my system. And if I was not able to incorporate a measure in the system, what is the procedure that is on the shoulder of the operators, for example, okay? That I'm controlling also the residual risk, the one that I could not take into consideration with the design. But if we go back to pumps, so with the traditional, we stick to the machine directive, which was published in 2006. We try to do this job, we follow a V model, and we try to argue based on the risk, okay? There is a novelty, which also caused a deviation during the last sprint, and a deepening of what was going on from a regulation perspective. Okay, by July 2023, it is expected that the machine regulation will be published. Now it has been accepted. What does it contain? Well, it contains requirements regarding cybersecurity, okay, protection, and the link to the Cybersecurity Act, a implicit but present link to the Cyber Resilience Act, and also implicit but present, because they talk about evolutionary behavior, with the Artificial Intelligence Act, okay, which is still a proposal. The Cyber Resilience Act is also still a proposal. The other one, Cybersecurity Act, is published and enforced. So, and I would like to add also that there are other regulations that we might be interested in. For example, the one on energy efficiency, decarbonization. Why is that linked to the pumps? Well, it is linked because we were talking about water management, right? Water supply management. And why do they want to digitalize this? Because pumps are consuming 10% of the energy. And if you're able to manage the water supply in a more intelligent, smart way, etc., you can reduce the energy and increase the efficiency. Okay. If we consider the window lifters, same thing here. We are in the automotive sector, and we see that there are standards, UNECE regulations, and there are standards not only for functional safety, for safety of the intended functionality here, but there are also standards for cybersecurity and a pile of standards under development regarding artificial intelligence. Okay. So, what about the safety assurance of liquid products? It cannot be just safety, right? I cannot work in a silos anymore. I could, and I could even laugh. In the 70s, in the 80s, they were laughing during conferences. This is what I read. They were laughing when there were people raising their hands. Oh, but we should care of the interaction between safety and security. So it's not that people are just waking up now. It's only that before it was not that needed, okay? Now it is needed. So we need to understand the interfaces between the different regulations. Why? In order to understand, because of course, we want to comply with the different regulations, and also we want to perhaps spare some time, right? And understand in which way they are overlapping, and when the article is saying, okay, you did the job here, you don't need to do that again here, okay? So, how can we show the required traceability? How can we handle the configurations? How can we cope with the constant change? How can we increase the guarantee for a balanced added value, added risk? So Jan Bosch mentioned only the added value, right? I'm here because I work on safety, and I'm here to remind you that, okay, there will be added value, but there is also a lot of added risk that we are observing, okay? I'm perhaps more observing than you because I'm connected to a lot of safety people. So every evening I see a post on LinkedIn, or I see the news also because I have to prepare the exam for my students regarding dogs that are killed by these automated vehicles, okay? Or accidents because of beta testing functionality delivered, and fortunately the driver is still keeping the hands on. In cases in which the hands are not on, if you just rely on the functionality, could be dangerous. Okay, so balancing between added value and added risk. We are here, some of you manufacturers, some of you just consumers, right? So it's good to be informed. I think that we need a multi-constant frame of reference. This is what I'm claiming. not only looking at safety, and this is also what is recommended by the standard on open systems dependability that I'm mentioning. And this is for what? For continuous quality assurance, continuous multi-consent assurance, continuous risk assessment and management. I haven't highlighted the continuous aspect here yet. I have stressed about the multi-consent. The continuous is due to the fact that we are in constant change, no? And Jan Bosch this morning was saying that this cycle is shortening. And we need to understand this balance, and we need to understand how to exploit the data from the fields in order to be able to do this continuous, because otherwise we are just in the engineering branch. So preliminary results, since we need to build this frame of reference, a possible way to build it is to start formalizing the commonalities and differences among the products, understanding which is the machinery type. So at this level could be a machinery line, no? Are you a pumps producer? Then you instantiate with respect to pump. Are you manufacturer of robots, co-robots? Then you expand and you consider if your machinery is connected evolutionary. And if it is the case, then you will select specific regulations, as here that we play with the regulations that I mentioned before. It's not that we need to understand this drawing here. The message is there is a possibility to explain, to formalize how to include, exclude chunk of requirements to which we associate chunk of evidence with respect to the requirements that are pertinent to the product that we are actually developing and delivering. Okay. Another piece of solution is the socio-technical perspective on this. It's not this adaptation is part of my work in cooperation with Bosch. Okay. But we are building on the shoulder of a giant, Rasmussen, who was working on socio-technical systems and was observing the different layers that you do not only have the product, okay, but you have also to take into consideration the normative space. So what is going on at the government level, what is going on at the agency that deliver the regulations and the standards, at the company level, all the norms that are decided through this process, and then the engineering, and finally the field data. Okay, so if we have all this information, we can feed what? A graph database. Okay, we can link this information together, and then we could have the possibility to query the database with SparkleQL, and we could have an assurance case code generator. So we have the copilot for co-generating the code. We could think of having a kind of helper with respect to the assurance case generator. Actually, we have been working on generating assurance fragments of assurance cases since a long time, and this is doable. But in a larger scale, graph databases seems to be a possible solution. Also, in the computational law community, there is a lot of work in formalizing in RDF graph the information with respect to regulations. And why this would be of interest? Because you could tune the pace. We want to shorten, but how and how in which context we want to shorten it, and how short should it be for the nuclear sector. I'm also mentioning the nuclear sector because even in the nuclear sector, there is the necessity of digitalizing, even though they are still trying to find patches to maintain exactly as it is with respect to the design of the 70s. but they are in the process of digitalizing. And I was attending an interesting talk from a guy from the agency in the US who was saying that the barriers are falling down even in the nuclear sector. And there is a lot that needs to be learned, okay? Because we are losing those barriers. So, which is the pace? Is the pace for nuclear the same as for automotive, or the same for an infotainment functionality? There is difference, right? So this could help, because this could allow us to write a query in order to get an answer in this huge amount of data that you have to think that is present, and we need to handle it. And manually we cannot. So another fragment of solution, we are looking into how to formalize this ontology in RDF graphs with respect to the example of the window lifter. I'm not going into details here, it's preliminary work, okay? And we are building on top of other works, and we are exploring different solutions. Not only, so RDF is to draw the ontology, and then how to validate this ontology. So we are exploring this different possibilities to validate the ontology. Future work, reiterate on the proposed preliminary results, incorporate planned increments, step-by-step ontology creation. To have the case to demonstrate that it may work, and for the moment we are staying within the window lift example that we have identified, and the pumps. Questions?